Okay, so I'm starting off the hour with a little bit of proving. That's what this test is like. You're going to get proofs. Prove this is equal to that. All right. So I gave the kids a few minutes, and the first thought was we should change this. And we went through two options. We could either say 1 over tangent, but think about it for a second and quickly rule it out. Why? Because it doesn't really get me to that. Like, sine and tangent can't cancel each other anyway. So then, sir, you suggested maybe the other option. What was that other option? All right, and why might that be better now that you're seeing it on your paper? Yes, look at that. Now that these are next to each other, you might notice that, ooh, I can cancel those. Is that simple math? Yeah, you're allowed to do simple math like that. All right, and then can I just jump right to the answer, which that this is equal to secant? Nope. I can write cosine, because that's what it is, cosine, after I've canceled the two signs. And cosine equals 1 over secant. And again, you might be annoyed at these rules, but you can't leave it that way. I know it's on the sheet, but you can't leave it that way. You've got to finish by replacing the cosine with a 1 over secant. It's the rule. You have to keep going until the left and the right side are identical. It seems so like, oh, that seems so stupid. Well, it's comparable to a cop seeing a bad guy walking down the street. He knows from past experience this guy's been a drug dealer. He's got his pockets stuffed full of stuff, and he's just putting his wallet away like he just got done with the drug deal. He can't just walk up to the guy and say, hey, show me what's in your pockets. So, okay, maybe it isn't even, well, he might have just sold all his drugs. Good point. The point is the cop can't just walk up to somebody and say, hey, show me what's in your pockets. That's illegal search. Even though it seems like it, hey, let's try to catch the drug dealer. There are rules. You got to follow these rules. You can't just say, hey, I think this guy is the person who abducted this kid, so let's go search his house. You have to get a judge to say, here's my evidence that this is the guy. You can't just go searching people's houses. It's against the rules. All right. So there are rules that sometimes are annoying in the real world because you think it's going to be better if you can just break that rule. And anyway, this might be that way for you sometimes. Like, how come you can't just go, I can see that it's going to go straight from here to here. That you can't just skip steps. You got to show me every single step. Okay? All right. Let's try another one. Show that the left side equals the right side. And it looks kind of intense. So you're driving late at night. You're not doing anything wrong. Like, you're not speeding, you're not weaving, you're just driving. Cop pulls you over. Can he make you do a breathalyzer test? Why? That's a search. Yes. He has to have probable cause. He has to have probable cause. He has to say that he smells alcohol in your breath. Then he has probable cause to search your breath. Okay, anyway. Back to, is there one that you can't read up here? Sine plus cosine over cosecant, secant. Seriously? Sine, cosine, cosecant, secant. There is nothing on the sheet is ever to the third. Oh, okay. This is squared and this is squared. I will give you that 2 right there is a little weak. I'll fix that 2. That's a 2. Still pretty bad, but it's a 2. I'll keep it simple for you. Every single thing in the problem is squared. Okay, is that multiply? That is multiply. And any two things that are sitting next to each other without a sign means multiply. Prove that those two are equal. which is right. Only one side at a time. Can't change the left side and the right side. You can only do one side. All right. I've been hearing kids debating this. I want to settle this debate. You guys know that cosecant is 1 over sine, right? But they can it also works if they're squared. If you didn't know that, the reciprocals are still reciprocals even if they're squared. So I know some of you are thinking about getting rid of like cosecant squared. Yeah, you can, there is a reciprocal for that. Every function has a sister function. That's the reciprocal of it. All right, so yeah, even if they're not squared. So if you look at the sheet is going to say not squared things. All the reciprocals are not squared, but they all can be. Same with the ratio identities, like tangent equals sine over cosine. Tangent squared equals sine squared over cosine squared. All of those can be squared, and they still work. All right, I think some of you guys might need a little bit of help, so let's let one of the kids out there who thinks they've made a good discovery give us a suggestion. What did you replace with what? Mr. S. All of that simplifies to a 1. You are correct. Do you get that's one of our things on the list? Sine squared plus cosine squared equals 1. So I'm going to replace all of that with a 1. Good call. Now, if it helps you, you can do simple math. Have a good day. Like breaking these up. Now, you don't have to do this. I'd be okay if you did it without this step. But do you get this is the same thing? I just broke it into 2 pieces. That's that times that. And that does make it look a little cleaner. Because I bet you can find 1 over cosecant up there. And what was 1 over cosecant? Sine. And I bet you can find 1 over secant up there. Cosine. And I think I just did it. Yay! There it is. Notice I followed the rules. I only messed with one side. And when it was all over with, the left side equaled the right side exactly. And I only did swaps that were on the sheet. That's on the sheet. That's on the sheet. Now, as much as you are going to have the sheet, if you have to look up every single time, like, what's sine? Oh, I don't know. I'll look at the sheet. Oh, 1 over cosecant. It's going to go really slow, and you're not going to be good at this. Okay, so you got to know those sister functions like the back of your hand. So let's just take a second. I'm noticing a lot of people struggling with that. And it was not just your hour, other hours too. What's sine's sister function? Cosecant. And if you know you're one of the kids that doesn't like know these, better write them down. What's cosine's sister function? Secant. So this is 1 over cosecant. This is 1 over secant. And what's tangent's sister? And those are called reciprocals. All right, those you got to know. And then again, I could have squared everything on the sheet or everything on the board right now. I could have squared it off, and it would be still true. And I should have an angle for each thing. Sorry. And squared, 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 squared. Okay. All right, awesome. Now I got a mind bender. Could I, if I wanted to, replace the 1? Instead of replacing something else, like saying, oh, that's cosecant, could I replace the 1? Yeah. What do we know 1's the same as? Sine squared plus cosine squared. But wait, there's more. I could have replaced it with sine squared plus cosine squared. God, I must stop talking so fast. But what if I wanted a tangent involved? Do you know some little saying about the one with the tan? You got it? And you're exactly right, but can you tell me first, what's the one it started with? So for people at home that are like, I don't really get where you're getting that from. Yes. And that one is on the list. The one with the tan is what you seek. And then you could solve it for tangent. Subtract 1 from both sides. Tangent is secant squared minus 1. All right. So my point is you need to know that you can solve things that are on the list, like that one we just did. And we could solve it for 1 also, and that's what you did. How did you solve it for 1? What did you do to both sides? Tangent squared. Very good. And why did you do that? Because then you had 1 alone, and then you could replace this 1 with secant squared minus tangent squared. Okay. And now we need to take a moment for factoring. Would you agree if I had this, that it can be factored? You forget how to factor that? It can be factored. What is it? X plus 5, x minus 5. So why do you think I'm saying that? Because you just said, was it cosecant minus, no, it was secant minus tangent? Is that the one you just did? Yeah. Okay. Secant squared minus tangent squared. Do you get this is a perfect square and this is a perfect square? And so the same principle applies. This is why I made you do the top 20 to make sure you had your basics down. Because do you get, if you didn't understand how to factor x squared minus 25, it's going to be really hard to convince you that you can factor that. Everybody please factor that. Tell me what you think you get. Because if you can factor it, you should. A lot of times, that's the solution on really tough questions. And let me tell you, again, the reason I've made it my favorite saying is because usually in this class, at the hardest moments, it's one of those things that often comes through and saves the day, like, oh, and then you can factor this. All right, did you get secant theta and secant theta, and plus and a minus, and tangent theta and tangent theta? Raise your hand if you had that one right. Okay, awesome. Now let's see if you can get this one. It's very similar. Secant squared theta minus 1 over secant theta minus 1. Obviously, everything is in context. I just talked about factoring. So, I'm going to pause for a second and give that a try. Can you say the top again? Just, I think I may have misheard you. Not, what do you think it should split it up into? Can't do that. I mean, you can break this into secant theta times secant theta. That is true. I shouldn't say you can't do that. You can do that. But that's not going to allow you to cancel this, which is, I think, what you were going for, because this minus 1 here isn't part of the factoring. So very creative. I've never seen anybody try that before. Wouldn't work, though. What do you think? Let's see how she did it. That's a way you can factor it. And now, stuff cancels. What cancels OC? And here's another one that kids do all the time. So this is the final answer. Yay, this is it. Do you get that some kids think, oh, it's just something squared, so I know how this is going to work. I'm going to get rid of the squared, and I'm going to cancel that whole thing, and it's secant minus 1. No. What was the actual answer? Secant plus 1. You got to show your work. Don't try to take shortcuts. That's a classic shortcut that doesn't work. You can't just cancel off the squared and cancel off the bottom. That won't work. All right, let's do one more like that. Oh, wait, I'll square it on the bottom. Hint, if you can factor it, you should. On the top. Volunteer? Yes? Man, you're doing these unusual factorings. You might even be right. You might be right. But here's how I was expecting you to factor it. And you tell me if it ends up being the same as yours. Okay. Okay, all right. So you just, oh, I see. You just rearranged like these two. Okay, I get it. I just wasn't hearing you right then. All right, awesome. Now, what will cancel on the bottom? 1 plus sine theta. Because there's something exactly the same on the top and the bottom now. Boom, ba-doom. And then the answer is 1 minus sine. Okay, so if you can factor it, you should. And there's lots of opportunities to factor in these things. Anytime you have a minus sign, okay, in other words, did I ever ask you, well, actually I did. I asked you to factor that, but only with imaginary numbers. Do you even remember? You can't factor this unless you throw in that special thing. X plus something, X minus something, and it's kind of like 5, but what's missing? What do you need? In case you forgot, it's like that. Because when you include the extra I squared is -1, and it would all work out. But bottom line, normally kids just say you can't factor that. And they're right, unless you use imaginary numbers. Okay, so what can you factor? X squared minus 25 can be factored. So anytime you see a perfect square and another perfect square and they're being subtracted, you got to think, ooh, I could factor that, which happens a lot. Look on the board once. Now, there's nothing with a minus in it in the first place on the whole top of the board, but there's the Pythagoreans. All of them can be arranged so that they could be a minus in them. Do you get how that one could have a minus? These are facts, so I can do anything I want to both sides. They're truths. So unlike the proofs, where I can't like add 2 to both sides, here I could subtract cosine squared from both sides. And do you get, all of a sudden I've got something with a minus, and 1 is a perfect square, and so is cosine, and then it can be factored. All right, let's do something like that, except with the one with the coat is, remember the little snappy saying? Cozy. Make that into something that could factor, because the way it is right now, it can't factor. Make it into something that can factor. There's 2 ways to do it. Who can tell me something I could do to both sides that would leave something that could be factored? Yes, I agree. If I subtract 1 from both sides, then that one's gone, and now cosecant squared minus 1 could be factored. into cosecant plus 1 and cosecant minus 1. All right, what else could I do? Instead of subtract 1, I could subtract cotangent. Why is that good? Well, the 1 can't, well, 1 can be factored into 1 times 1, but this could be factored into cosecant plus cotangent and cosecant minus cotangent. All right, yes? All right, so hold on. I think you're going to end up getting one of the ones we had in the first place if you do that. Okay, so it's an okay thing, but it's like doing 2 steps to get back to one that we got earlier. So yes, you can do that. Okay, so last thought. Oh yes, common denominators. Make these have a common denominator and add them together. What does this have to do with trig? In a moment, that's going to be like 1 over sine plus 1 over cosine, and you'll have to get a common denominator. If you don't remember how to do it with simple variables, and even more simple than this was when I gave you the top 20 and made you do common denominators with simple numbers. If you've forgotten it, maybe go back and remind yourself. I bet you still remember how to do this. Get a common denominator for that. Then you can get a common denominator for this. And then you can get a common denominator for sine over cosine plus 1 over cosine, that kind of thing. Okay, in case you forgot, this one, you times both sides by 3 over 3 and 2 over 2. That'll give you a common denominator of 6, and then, you see what I mean? So what do you do on this upper one? You times the top and the bottom by something. Don't say it, please. Let people figure it out for themselves. But would you please compare with your partner and see if you got the same thing? Who do you need? All right. Want to say last name? Just in case I have to. Maybe he's not even here. Ah, there he is. Good. All right, so on this one, you should have multiplied by 2 over 2, and in this one, x over x. Final answer, 2 over 2x plus x over 2x. Can I add them now? Yeah, they got a common denominator. So it's 2 plus x over 2x. Raise your hand if you had that one right. Okay, then see if you can add this. What's 1 over cosine plus 1 over 2? I should have a theta in here, because cosine by itself is meaningless. Cosine of an angle. 1 over cosine plus 1 over 2. Get a common denominator, add them all together. We're going to get it down where there's only a couple strategies left. And then from there, it's just a lot of practice on Monday, Tuesday, Wednesday in solving and proving, I should say. Pause for a second. Okay. Should have multiplied this one by cosine over cosine. Do they have a common denominator now? No, not quite. The left side needs to get multiplied by what? 2 over 2. Final answer, 2 plus cosine on the top. And what's the denominator? 2 cosine. Awesome. Now, I'm not saying that worked out, oh, perfect, everything canceled. But you need to know how to find common denominators, because on the test, the typical question has finding common denominators on at least one of the questions. It's going to come up. Okay? All right, so here's one where you could actually use that. think. I'm going to pause. Okay, this is a little too easy, but use a common denominator to prove that one. Use common denominators to prove that that's true. Again, the real test would be a lot harder than this, but at least you can use a common denominator. So did you swap out sine for 1 over cosecant? That way they have the same denominator. That one already had a denominator of cosecant. That one needed a denominator of cosecant. Now it does. Now they have a common denominator. Now I can add them together. Well, maybe even before I do that, I could change them both into sine. But I did say to use a common denominator to do it. Because if you just change this to sine right away, then you just did sine plus sine is 2 sine. But you didn't use common denominator. All right. I know the one I gave you just now was a little too easy. That one's sine. That one's sine. And it does equal 2 sine. And these two together make 2 sine. And then I'm done. And I never touched the right side. And I never broke the rules. Now, you wouldn't have had to do it that way. There was a different way. But there's going to be several where I can't process one right this second. But where you're going to have two fractions, a fraction plus a fraction, and it'll equal something simple like sine. And how is two fractions going to be added together and equal something not a fraction? Well, you'll have to get a common denominator. And then you'll be able to add them together. All right. I think there's one of these in the practice for today. So we're going to find that next. I'm going to pause for a second to get on the right slide. Look at this one for just a second. This one is pretty simple, but I want to dispel a thing you're not supposed to do. Don't just go like that and that. A squared and a sine are not the same thing. You can't cancel them that way. If you want to cancel them, you can, but only if you do it the right way. Sine theta times sine theta over sine theta. Only two things that are identical can cancel each other. It's not okay to go like that. That's just shorthand, and these are proofs. Okay? So you should replace sine squared with sine times sine. Here's one. Hey, got one. Where you need a common denominator. And once you have the common denominator, you could prove this one. So the left side's obviously more complicated. Start there. Try to find a common denominator. And then prove that this is true using that common denominator method. Did you realize that you could replace cosine with 1 minus sine? Why can you do that? It's on the list. Still going on. It's on the list. Where is it on the list? Sine squared plus cosine squared equals 1. If you rearrange it a little bit, cosine, if you just subtract off this sine squared, that happens a lot. Watch for those. You can get something to be 1 minus really easy because we got a lot of things where they're adding 1, tangent plus 1. You set the minus 1 from both sides. Or the one that says cotangent plus 1, it's minus 1 from both sides. Would you explain to Mr. CA what assignment we just collected? Partner? Okay, thank you. All right. So Final answer? Well, now that they have a common denominator, you can add them. And that becomes 2 over, and what is the same as 1 minus sine squared theta? Sine squared theta, that's that one we just did a second ago. And that is cosine squared theta. So this is 2 over cosine squared theta. But it's not secant. I just realized I had it on the last hour and I forgot to change it. This is supposed to be 1/2 and this is supposed to be 1/2. That way when you add this plus this, it's supposed to be a 1 on top, and it's a messed up problem. But if you got here, you were really close and you were doing it right. It's just that your 1/2 plus your 1/2 would make a 1 over cosine, which then one more step and I'd have it. And I apologize, that should have been a 1/2 and a 1/2 on the top. Okay, yes? Yep, it still wouldn't have worked with my screwed up problem. But yes. Yes, there's more than... Yep, you're absolutely right. What she's saying is if I go back here to the beginning, at the very beginning, instead of... Oh, what just happened? There. Instead of crossing this one out and going that route, which worked, other than my problem being messed up, I'm going to change my problem to 0.5 right here and 0.5 right here. Now it'll work. She's saying you could replace the 1 minus sine squared with cosine squared. That's totally okay also. And it gets it faster because it's a smaller denominator right off the bat. So that would have been a good one too. And then 1/2 plus the 1/2 would be 1 on top over cosine squared. And what is 1 over cosine? It's secant equals, bring that down, secant. All right, what are the rules again? Can't touch one of the sides. You can only touch one of the two sides. And then can you add something to both sides of these things? No, you cannot. That's going to be very tempting in some problems. If I could just divide by cosine on both sides, I'd be done. Can't do that. Not allowed. Got to follow the rules. All right, so let me get you to your homework. So I'm pausing for a second while we find that. Okay, so here's your homework, and you might as well start with the person that you're with right now. And you have these two problems. You have to prove, and at least unlike my problem I just did where I messed up, these have all been proven to be true. So we know they're true. The first one, number 86 there, that's pretty easy. The second one's not so easy. All right, I'm going to add one more strategy to your list of strategies that are handy. And that is something called a conjugate. That right there could be multiplied by 1 plus secant. If I do it on the bottom, I have to do it on the top. That's called the conjugate of this. Doesn't that look like what you get when you factor 1 minus secant squared? I don't know if you caught what I just said there. If you did, you could do this to the other side too. What's the conjugate of cosine minus 1? Cosine plus 1. And if I do it on the bottom, I have to do it on the top. Those are called conjugates. Now, if they aren't necessary on today's homework, they are going to be necessary in the future. And I am going to go over that again on Monday. But I'll give you a really simple one. 1 over x plus 1. What could I multiply that by? Anybody catch how from that super fast description of what a conjugate x plus 1 would be? X minus 1. And why is that cool? Because what's x plus 1 times x minus 1? X squared minus 1. Yes. Those are called conjugates. They started with cosine minus 1, so I multiplied by cosine plus 1. They gave me 1 minus secant, so I multiplied by 1 plus secant. that's a really good strategy, and it's not an easy one. All right. So there's some of these that are going to be tough. I warned you it was going to step up fast. So one of the reasons that I was telling people this class is tough. Are you sure you want to be here? Because, you know, you'll get through this test and everything, but it's not going to be easy. The test is coming on Thursday. All right. If you have trouble with this, you just got to look through the answers and try to figure out, oh, I see. I see what they multiplied by. You got to really wade into them and figure out what did the teacher do to solve this problem. Okay. All right. And again, you aren't good at this yet. You will be good at it, at least good enough, by Thursday, because we'll have had Monday, Tuesday, and Wednesday to practice before you take this test. Okay? So don't despair. These are tough. They always have been for every kid that's ever taken honors pre-calc. This is always a bear of a chapter. That's why we have that easier grading scale for the test too. Okay? But it can be done. On this one, do you see that there's an arrow from the 1? Does that imply they're going to replace the 1 with something? We did talk about that. Remember how all those identities that you can solve for the 1? What could you replace it with? Sine squared plus cosine squared. But that one's not going to help much. Do you know if I put sine squared plus cosine squared, do you get how that doesn't match up with these very good? But there's something like that that you could put in. Don't say it. I want people to figure it out for themselves. It's on the sheet where if you solve it for 1, you'll end up being able to put something with cosecant and cotangent right there. And obviously, that's what you want to do, because then you can get them to cancel with each other. All right. Same thing could work here. You could replace the 1 with something like cosine minus 1, or cosine squared, or cosine squared plus sine squared, or... All right. Make sure if you don't get them that you at minimum go back and do them anyways with the coaching of the key so that you're understanding what the process is. Okay, that's all I got for you for today.